Oh, great, we're ready.
Make sure you hold all the passwords here.
Luckily, I don't have to show any passwords for this, but there are passwords. There are passwords in this, but they're all hidden. So yeah. I can actually type. I can.
You have the bar on the top turned red and say it's recording on your side? It's recording. We have it on his side.
Let me see where it's.
It might not do it right enough.
Yeah, it does show the recording in the top left.
Good.
All right.
Vanity check succeeds.
Where we're here.
The fact that it's able to share a screen from just a web browser is kind of impressive. I'm kind of wondering how they're doing that.
Yeah, I use it all the time now for web conferencing. Like I work fully remote for this. Okay, so
what is the name of the tool? Zoom.
This is just Zoom in the Chrome web browser.
Yeah,
Works in Firefox just as well.
There must be a thing for that now. I'm not sure what I think about JavaScript API for scraping the screen.
So I guess to start this off, who here has experience with Kubernetes? Yes. So I guess it's a pretty...
I'm eventually going to take my CKAD, but...
Okay. With that then, I guess so I can go in, if you have any questions, I can go more into detail with any of this stuff. Right now I'm going to be running a lot of things that I have pre-scripted, okay. Just because there's a lot of steps to get all of this working together. So this is in the DevOps Knoxville demo 2019. I can post this in the Slack again if you guys want me to. In here, I guess maybe I should first, I need to run this because it's going to take it about 15 minutes to get to the next step. And then I can talk about what it's actually doing. I probably need to log in.
Do you have any thoughts on Helm 2 versus 3?
To be honest, I've never used like Helm that deeply. I've written one or two of my own like templates before, but other than that, I usually just use like the Helm templates online. So I don't know too much of the differences.
I actually just wrote an article on Medium about using kubectl, which is basically a UI you can deploy like Google Cloud and stuff like that, and basically you can search a catalog of Helm charts and you click to deploy them to your infrastructure.
Oh, okay.
It's really nice. There's a lot of nice little UI things you can deploy to Kubernetes now that kind of visually do a lot of things.
I'm not
What
seeing
is
this.
happening
Where did
here?
you post this on Slack? What channel?
Yeah, why is gcloud not working for me? I'm sorry, guys. This is I ran this twice last week. So this command should. Okay, what did I do here? Let me just get this.
Not in the DevOps channel. That's why I didn't see it.
Let's try that one more time. Okay. You should have all my environment variables in there. Because I didn't do Kubernetes setup. Okay.
Oh, you were doing it in the wrong order?
All right, so what is this script doing? It's going to just think for a little bit. But what it's actually doing is it is creating a Kubernetes cluster on Google Cloud. And I guess I can show what exactly is going here. So we can imagine that there's going to be, has anybody used node pools before in Kubernetes?
Yeah, and I've used them in like GK just a little bit recently. I don't really know why.
Okay. Yeah, so what you can do is you can create these node pools, which are where like just arbitrary nodes will pop up inside of them. And they can have certain labels. So here we can have like just general, and this can be, let's say, like a CPU worker. And then over here you could have another specific group. So the benefit of this is that you can request for your containers to run on very specific nodes. And you also have policies that say that you can't schedule a pod on general nodes, like it has to be scheduled on a different one. So the general architecture that's going on here is I'm using something called Jupyterhub, or Jupyterhub. Has anybody here used Jupyterhub or Jupyterhub Python based? So it's a language agnostic interactive development environment on the web. So you can run, for instance, a Python kernel, you could run an R kernel, you could run Ruby, Haskell, like you name it. So it allows you to basically develop remotely. And another one of these big benefits is that you can run it in Docker containers, so you can control everything we have installed on the machine. So you, as say the administrator, you want to say we have some like special packages in our group, and we'd also like them to have like blah 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 Python packages, and these are packages as well. So you can have that all ready for them, and they don't have to deal with installation. You can firewall everything and prevent them from using like apt-get and all these other tools. So you just get this like user-controlled environment, and people don't argue about, hey, I couldn't install this, and I couldn't install that. So what's going to be going on is that in this general space, I'm going to have right now 2 1-core CPUs running, and then in this other node pool, I'm going to have the Jupyterlab environment. So anytime a user wants to start programming in their Python environment, it will spin up a user on this Jupyterlab node pool. And then the next thing is that oftentimes people, when they're doing like data science and computing, they need to scale up really, really fast and run on, say, 1,000 cores. So we need this other benefit that here we have these Jupyterlab is where each user is actually developing on. And then anytime they want to scale out, they'll, for instance, use these CPU workers, and they'll take up maybe 1,000 nodes for their job. And then once that dies, they'll go back to their environment here. But the benefit of all this auto-scaling technology is that you can, the cost, if nobody's using your cluster, is just the general, like just the 2 1 CPUs. So you can be nearly free. I've been running this at our company Quansight for about 2 months now, and it's cost us about $100 a month, something like that. And we've had people spin up to maybe say 10 nodes for an hour or so, and then gone right back down. So it's a very general approach here. So the things that are going on right now, I guess we can kind of, well, let's actually look at it on the interface because it's a lot cleaner this way. Okay, so this is this is Google Google Cloud, and here I created a project called DevOps Knox, and inside of here, one of the features that they have out of many with all the cloud environments is their Kubernetes environment. So here we see something is spinning up. The cluster size is 2 nodes, and these 2 nodes is just this general node pool right here. This is not only, I can probably make it bigger for everybody. Okay, if we click in a little bit further, we can see where it is in the process. And this is the longest part of the, creating node pool, user pool. So I forgot what I called this, but I called this the user pool. And then, so if we scroll down, here we can see on the very bottom, default pool, okay. And this is the, this is default. Pool, and then user pool, and then the last one is going to be the CPU worker pool. So this is, and here we can see the restrictions. So number of nodes is 0 here, number of nodes is 2 here, but if we click on the user pool, we'll see that this has auto scaling on it. So this goes between 0 to 2 nodes. But right now it's not costing us anything there. It's also, since it works really well with Kubernetes, it spins up the disks and everything else that's required for the cluster. Does anybody have any questions at this point? Just kind of what each one of these pieces are?
Kubernetes is way easier on GCP than it is on. I mean, they've made it, but I feel like I've been using it on Google Cloud Platform recently. I was just amazed at how much easier it was in KS.
Yeah, I know they make it pretty easy to spin up. Why did
It's
that?
pretty slow though.
Yeah, for them popping up, it does take a little bit. We can see this is the commands that I ran to start the whole cluster. Cluster create. I said the number of nodes. In this case, it was 2. And then you just say where you want it to spin up. And then the rest is a lot of permissions things. And then going down to the bottom, this is what it takes to get on the very top, we see the user pool. It goes from min nodes 0 to 2. I'm applying something in Kubernetes called a taint. And this is saying, hey, don't allow anything to be scheduled on these nodes. So anytime just a generic person says, hey, I'd like to schedule some pods on your Kubernetes nodes arbitrarily, it will never allow them on here. So it's going to only schedule them here. And you have to do special stuff to allow it to actually get put on those nodes. And then the next one, so here we see what I called the CPU worker pool. And this one goes from 0 to 5 nodes. And the other thing that you can do with this is you can easily make some of these nodes, like this is a CPU worker pool, but you could have a GPU worker pool, and you could attach GPUs on these nodes as well.
So basically, by applying that taint, you're basically saying that that node pool is strictly for that specific thing.
Yeah, so you have to, it's a little bit more advanced, but when you're scheduling pods, you have to explicitly say that I have a tolerance for this no schedule marker on there. So you have to be very intentional when you're scheduling on those nodes.
Yeah.
And I'm doing that on purpose because I don't want just random processes to pop up on here and require more resources and cost more money. This is explicitly for scale out computation.
Yeah.
This one is for users. This might be a high memory node so that people can play around with their data locally.
Yeah.
And they can also these shared resources because not all people aren't going to be using 100 gigs of RAM all the time.
Yeah.
They might need it just for a short amount of time. So where are we right now? Okay, cool. So I think we're done with this part. And this is the longest part to get it to work. But I just wanted to show all the pieces. So if we look back at this, we go to the very bottom. Here we see CPU worker pool has 0 nodes running. We have the default pool, which has 2 running, and then we have user pool. So exactly as we expected, we just have two CPUs running in the default pool. And if we want to look at some of the processes that's running, it will look like there's, that's weird. There's definitely a cluster. Well, it'll pop up eventually. Not too important right now.
We haven't run that script yet.
Oh yeah, I do have to run the next step. All right. So then we'll talk about what the next step does. Okay, so this is setting up Helm on the cluster, and it seems like you've definitely run Helm before, but Helm is, they say it's like a package manager for Kubernetes. Really, it's just a glorified JSON template engine, and then it has a service called Tiller.
So Tiller's actually gone.
Is it?
Yeah.
In
So-
Helm 3, it's no longer needed.
Yep.
No, I did not know that.
Yeah, so they're still writing the migration docs for Helm 2 to 3, but for Helm 3, all of Helm is implemented using kubectl.
Okay, good. So this is probably an old Helm then.
Yep, it's
In that-
2.11.
Yeah. So here I'm using Helm 2. This will, I guess, change with Helm 3.
But the user commands shouldn't change. You just Helm in, it won't do very much.
And I actually think it would probably be a little bit more secure because I was going to talk about with Helm, it has to install this pod called Tiller, which is like the remote thing that controls how everything's configured. Is that the right way to say it?
Client server essentially. So Helm's the client side, and then Tiller's the server side that's actually doing the work. But now that kubectl has got a little more to it, it's used directly.
There's some things you can do for multi-tenancy where you can have multiple tillers and their service counts can be restricted. And then you have to isolate who can talk to what tiller, either for TLS or network stuff.
Huh. Yeah, here I think the setup some of the RBAC
This is a
permissions.
single user setup. So
Yeah, don't trust any of the security stuff that I did here. I'm sure there's some questionable stuff.
Everyone's admin.
I hope that's not the case. That is so weird that that's not popping up, but it will.
System workflows. It'll deploy tiller into Kube system by default, so it won't show unless you show system object.
Yeah, but it should have. Maybe they changed their interface, but before you were able to change the filters and look at all the.
Wow, so there's a big button for it.
Yep, like
there.
that. Yeah, that's what I should have there. All right, so then goes the final step, which I will talk about all the pieces that this last one is going to install because, so this is running all of the Helm pieces. So there we're seeing it's on deploying Jupyterhub. The next thing, sorry, it was picking up the Jupyterhub repository, installing something called kubectl, which is kind of an older way to get automatic HTTPS certificates. It's installing Prometheus. It's installing Grafana right there. And we'll talk more about these tools because if some people haven't seen them, this is a lot of stuff. Yeah, Jupyterhub right now is being pushed up. And I think that's all the pieces. I had Spark a little bit earlier, but I figured that would be a little bit too much to show. Okay, so we have all that. We'll let that. So workloads. Let's see if this one actually shows something finally. Okay, great. All right, so everything is kind of popping up slowly but surely. Some of the pieces that we have here, so we have Grafana and Prometheus, and these are, at least as far as I'm aware, kind of the typical applications that you use Prometheus for the monitoring, and you use Grafana for visualizing all of this time series data. Do other people use these tools at all?
I've spun it up, yeah.
I played around with Grafana a lot more than Prometheus because it can connect a whole bunch of stuff. Prometheus has got certain weirdnesses.
Only Prometheus, so I'll run the
I've
dashboard.
played with Weed quite a bit.
Okay.
So check out if it's Weed. If you're building an on-premise Kubernetes cluster, which networking layer you use matters. I'm trying to remember if it's Weave or if it's.
Weave generally doesn't get used for Kubernetes directly. We're just thinking of Flannel.
No, there's a step where you specifically pick one. Weave's an option, Flannel's an option. I think it's Flannel you have to use if you want to have a Windows worker node. And then there's a way to do ingress. You set up the software-based ingress. You have to have a particular networking module for that to work.
Well, because you have to be able to bring the Windows machines onto your overlay.
Yeah. Well, even without the Windows machine, if you want to have it play the same way it would if it was on the cloud, or over the load balancing.
I don't imagine there'll be anything too sensitive on here.
To save somebody else headache, you said that you're using Lego for the Let's Encrypt.
Yeah, and it works pretty well. I'm trying to get this the IP address pointing to it because it will be ready in about 10 minutes, something like that. And I can do a demo with how we actually have it running right now. But now I just need to find the IP address of this cluster. All right. So one of the things that we can see is this Nginx ingress controller. And this is how you would access the entire cluster, or at least it's kind of like it's the load balancer, but it uses Nginx, so it can route and trying to say the correct networking terminology. It's one above the IP layer that it can.
You call it layer 4, but Nginx is actually layer 7 thing.
Oh, great! So it can go even higher.
Yeah, Nginx is application. But for our purposes, we can just call the load down to the hacker.
One thing to save somebody else the hours of my life, I will not get back. When you want to move off of the cube Lego, the package you're looking for is called Nginx-Ingress, which is available as a Helm package.
Mm-hmm.
And that's what supersedes Lego.
Yeah, I think I was so used to using QA Lego. I used it like 2 years ago that I didn't even like really take the time to explore the new one, but I definitely should.
And there's a few other things that are coming in the pipeline where real certificates is an actual secret type for cases where you need to generate a certificate that's not going to go on the ingress. If you've got some weird node port stuff where you're doing non-HTTP things and you can use an ingress.
Okay. So I doubt this will immediately start working. I think it's even like refreshing. So we can get back to this in about.
All right. You can also just ignore the warning.
Oh yeah, let's do that. Good idea. Actually, I won't be able to just ignore the warning because
type, this is a bad idea. I think that's what it is right now.
what's visited on? I know on Firefox you can ignore it.
The only reason it's not letting you ignore it is you must have had HSTS turned on because it would give you a button otherwise.
So it's actually being pretty secure. Let's go on the other one.
There's a phrase you can blind type in Firefox. Or since you're in a container tab, you can pop open an index container.
Bad idea, or this is on site.
Yeah, you guys should all be able to visit this, and I've only given Andy you permission.
Broken.
Okay, so can I just do an incognito browser?
No, those still carry them. There are ways to remove them from there. Oh no, actually,
Yeah, advanced.
Yeah, incognito actually lets you do it. Or any other container besides 1065.
Accept the risk.
Yeah. And you shouldn't turn on HSTS for things like this, where you're using temp certs.
I'm hoping that GitHub will be okay with this. So this is Jupyterhub, and I'm using an OAuth authenticator that's GitHub for this.
GitHub doesn't care because GitHub never directly interacts with your server in this case.
But it's sending back the.
Your browser does that. It gets sent with self-posting form.
Huh.
Your site will need to connect to GitHub to verify the token, but OAuth doesn't actually. Well, that died in a weird way. Oh, that's forbidden. That's Jupyter tried to access some stuff in Kubernetes and was denied.
Uh-oh, guys. I'm really sorry.
I think that's an RBAC error.
That is an RBAC error.
Let me.
Oh, wait, was there another script?
Maybe I had to run that script. Let's see what my instructions were for myself.
Oh dear. It's not a demo if it doesn't go sideways.
Yeah, I can pull up the working one. Let's just go with working.
Oh, with the Wells Fargo one?
Yeah.
Get your horses.
All right. So here we go. It is launching up, and we can. There's nothing sensitive in here, so it's not a big deal at all.
So is this panel looking currently, is that part of Jupyterhub now? That it can automatically create the actual whatever the heck that part of Jupyter is called?
I don't know what it is using for Jupyterhub.
Okay.
So here we can see this is what happens. Right now we're in AutoScaling node pools, and there were no nodes existing at this point. So it's saying unschedulable. But what's happening behind the scenes is there is a node that's popping up. Yeah, so cluster size is now 3. So it used to be 2, now it's 3. And okay, so this one is not the one that we'll use for the demo anymore. Here we go. Okay, and I found that sometimes it's working when it says, okay, so it's still waiting.
Yeah, one node had unavailable network, so that node's probably not ready yet.
I saw that the ingress, it looks like the ingress was down. For the Wells Fargo cluster, it looks like the ingress was down.
What do you mean?
The ingress pod wasn't scheduled.
I think that was the other part.
Okay.
No, it wasn't that one. It was.
Yes, the ingress was the one.
There's your controllers there. I can't see that. And there's the proxy.
So we see now the pod is initializing, and it's now being spun up there. I can also show Grafana working as well. But this wasn't, I should have probably just had this spun up beforehand. I thought it would be really cool to get it.
Oh, it looks like it's spinning up. It looks like it's actually spinning up.
Oh, cool.
What is that password manager you're using?
So I'm using Rafi, which is kind of like the Mac OS thing that pops up.
Yeah.
And this is using something called Rafi Pass, and it is a Git repo plus GPG encryption. So
Kind of like how.
yeah, it is Pass.
Oh, it is literally just pass?
It's literally just Pass, but it's using a Go extension to it that allows me to do interesting things like
I thought it was TOTP.
here I have like OTP that I can
Which-
do.
I don't have technical concerns about the OTP like that, but it seems like they're defeated before.
Yeah.
What's your password?
I assume it's generating it, but it still seems weird for it to be on the works. Password.
Yeah, it's not so remote, but at least they have to know my GPG password to use it.
Yeah, well, we're not going to go into that.
So yeah, here's just some analytics and the Prometheus. Here we can see I did not spend any time setting this up. So this is just the default. If you tell it to use, we see some cluster usage percentage, file systems, all sorts of other analytics. I have this set up at my house, and it's really nice because you can see like your computer temperature, networking traffic. You can see if any disks are getting full. So it's just, Grafana is great even if you aren't running in a Kubernetes cluster environment.
I've messed with the Helm stack quite a bit. That's a fun thing for analyzing system logs.
Yeah.
Yeah, it'll leave all your disk space. But you can also use Elasticsearch for metrics pretty well.
Yeah.
And make them useful down to this. Metric view's gotten a lot better over the past few months.
Okay, so the actual demo, y'all. So here we have, this is a Jupyter environment. And I'm just going to scroll down here. So we can see things like, for instance, it's actually running Python on the server out there. And so here I'm using something called Dask Kubernetes. And Dask is like Spark, but Python specific. Has anybody here used Dask by any chance?
I use it a lot.
You do?
I use it on Summit.
I read his docs this morning.
So Dask has all these connectors. There's a Dask Spark, there's a Dask HPC, job queue. It's really easy to run anywhere, and it doesn't, I wouldn't say it's as heavyweight as Spark is. You can install Dask with, like, it has, I don't think Dask actually has any Python dependencies. So you can do pip install Dask, and it just works on your cluster. Other interesting things about it, talking like performance-wise, if you're dealing in a Python environment, it's kind of a pain to use PySpark because you're doing serialization through the Java client the whole time. So you get a lot of like performance hits if you go the Spark route. Also, the latency of Dask is a little bit lower than Spark if you care about how quickly a job gets scheduled on another node. So here we have a Dask cluster that is not so interesting because it's completely empty right now. But let's, just for the fun of it, use this Dask Kubernetes AutoScaling feature. So here I just asked for 3 workers. And what this did behind the scenes is it talked to the Kubernetes API. It scheduled 3 pods that would then connect to this running instance. And this number can go as large as you want, assuming that they've given you the correct permissions and and you've allowed it to auto-scale that far. So if we look back here, so Jupyter C Ostro C is running, and then here we see again unschedulable. So a lot of this stuff can be mitigated by, they have like fake users that you can schedule that don't actually take up any CPU resources, so you don't deal with these issues of like the nodes not actually being there. And
So pre-warned.
yeah, you just like pre-warm the nodes and make sure that you at least have one node sitting around so they can get started really quickly.
In GCP, can you scale it up? Can you scale it up while it's running?
I don't know the answer to that.
You can see where my brain went.
I've had to, I can say though, I've had a node that wasn't in Kubernetes, and I was just running like a compute instance,
Yeah.
and anytime I wanted to resize it, it had to restart the node. So I would guess probably no. All right, that's actually going pretty fast, but I wanted to show first, here we see that there are 0 workers, and I'm using something called, there's JupyterLab proxy, and you can expose web services. So here we see proxy 8787. So it's exposing port 8787. Yeah, but it's exposing it on the Kubernetes cluster. So you can actually start interesting things. So for instance, I could start a web server, and I can.
Okay, I guess I don't know Jupyter that well. I didn't expect it to immediately run that.
There we go. So we have a web server through HTTP running on that local node. So you can really.
Is there access control around this?
I imagine there can be. I know I was talking to a developer that was working on. It was Dask. I think it was like Dask Scheduler was the name of it, and it was to actually add some of this. Like you have to log in first before you can ask for 100 nodes.
What a concept.
But you could also have these sorts of controls like at the Kubernetes level where certain pods don't actually have the permissions to schedule pods.
And I think you do this quotas and some other stuff.
Yeah, I'm not too either. And I imagine that at the Kubernetes level you couldn't restrict it that well.
You can restrict what namespaces a user can deploy to, and you can set quotas on those. But I don't know if you can have a per user quota beyond giving a user a namespace that's all around.
Okay. I'm surprised that these haven't popped up yet. Let's see how they're doing.
Is that like refreshing? Oh, no,
These are like 2 GB Docker images, so maybe
oh,
that could be.
that might have something to do with it.
Might be why they're taking a hot minute to start back up. So we've got, this is a really interesting interface, the Dask. So I imagine there's something like this for Spark, but you'll be able to actually see every single function that's running on the cluster. You can see what order, you played around with the Dask UI, and I think if anything, it's just a really nice presentation show-off tool, but it's also really useful for debugging distributed tasks when you need to figure out what's going, like when are things actually running? Am I doing a lot of waiting? Am I sending a lot of networking traffic? There's just a lot of things you can do to look at your efficiency.
Now, the problem is if you do this on Summit, you don't have access to this.
They don't have this Jupyter, do they have Jupyterhub set up there?
No.
You'd have to run it through the scheduler itself.
You have to run it through the scheduler itself. And even though you have access to your nodes, I have not. There might be a way that you get access to the ports, but I haven't found it.
See if you can.
I've not gotten to play with it, but I hear you can use SSH for that. Because the login node can talk to all of its child nodes. So you have to bounce through it like you would any other bastion.
Hmm.
But I've heard those have even less software on them.
If you can, try to get this running, because this is such an amazing, this is how I enable any port you want to expose can be exposed through the UI. I've used this a lot at NERSC. They had this set up on their HPC center by default. Okay, do we have anything popping up yet? Still creating, gosh, that is a pain.
It knows you're doing a demo.
Yeah, it does, right?
I mean, you have.
Demo kit is super one.
Wanted to, any questions about this specific, what's going on here? Or I guess what will be. So I asked for three nodes, and there's three little pods. So they're just going to pop up right here. And I have the Jupyterhub instance that's right here, and they're basically going to talk to each other like that. And this can scale up to, say, if you want to have 1,000 workers, work just fine. Usually what you do is you put one worker per node, and then you'll just tell it, like, hey, you need 8 threads. Instead of like explicitly having 8 connections to one node, because it's like not as efficient. Still not, nothing usually pops up.
So is that like auto refreshing or something?
I think it does something like that. It always, I've always had good luck with it, auto refreshing. Oh, actually they're up.
They're alive.
Okay, they're alive. So we see our three little workers. We don't see anything here, but let's just do that again. Oh, you know why I wasn't updating? Because I had a web server running. Okay, so now we have 3 workers, and
I don't understand Jupyter at all.
so you can do out of order execution. It's just the cell that you actually have.
You can only have like one cell that has an asterisk in it
At any given,
at any given time. So it's basically,
because he was doing the other one, this one wasn't executing.
Yep.
The program counter was over there.
So it's not showing that right there, but did it just lose them? Yeah. It's because I refreshed.
Oh, and it destroyed it.
It destroyed. So that was actually, this is a good thing. This is showing that these things that you see running right now should disappear if I did it, if it's running properly. That's
They might have to time out though.
they usually just die immediately. No, this is not the greatest demo.
on the other hand, this is maybe showing more real life conditions.
There they go.
I'm sure the next.
Yeah, I should have recorded the whole thing. All right, so
We're recording.
what a pain. Yeah, it is recording the whole thing. It says they're running, but
Oh, it's warning though, so
Why?
it might be failing checks.
okay. Well,
It's making 2 more.
yeah, it's making 2 more. I'm just going to show a little quick. Yes. So the web UI, if it was running, Matthew Rockland is the creator of Dask. But this is what you would expect when you're running some tasks. So you have this, like, I guess it's a much more updated interface nowadays, but you can see what's running on each worker, how busy they are, their CPU usage. You can also, the new one has like red to indicate if it's doing networking while it's actually going on. So it's just it's a great tool. And yeah, I've used it. I guess here he's showing, yep, he shows it better. This is the AutoScaling where he asked for a few more nodes or workers and he got probably like 20 or 30 more.
So that's seriously distributed nanny.
Yeah, they have, the nanny watches to see if a worker dies. And then if a worker dies, it will respin that worker up on the node. But a really, really awesome tool. And if anybody here, I'm sure people are using Spark. If you have Python workflows and you're trying to use PySpark, you should probably be using Dask instead. It has a lot more features and it's not as heavyweight than Spark.
It's pretty easy to set up too. And in my case, what was appealing is it didn't use MPI.
Yeah.
Yeah. So it basically uses plain old TCP IP sockets, and it uses CloudPickle, I guess, to communicate between the scheduler and the workers.
Yeah.
So yeah, it was very easy to set up.
Yeah, and it uses CloudPickle because of, I'd say pieces that are lacking in the Python pickle. In Python pickle, if you try to, do people know what pickling is in Python? So it's kind of like serializing a function and then sending it off to another node for it to run. That generally works, but if you have a function that's in the wrong context, it won't show up properly on the other node. In this specific case, it's dunder main, doesn't show up. Python treats main a little bit differently. They're showing some networking. So yeah, just an awesome tool. I recommend there. Last shot, and then I will just call it quits on this. Oh, great. Okay, well, I think we can say that's pretty much it. But this, I know it didn't run nearly as well in the demo, but it actually runs quite smoothly when I'm normally using it. I don't know how to explain that. We had about 6 users simultaneously, all on different, they each had their own pod and user pool. And then we were able to, like I said, we had about 20 or 30 different pods that we scheduled on the workers. And it wasn't that expensive. I was saying one of the things I think is really attractive about this is that you really, if you're not using it, you're only paying for this. And that's like 2 CPUs. So basically free, especially if you've got a company paying for it. Cool.
Yeah, and we have caves.
I shall say nothing.
Okay. And it's so so this is an Oriental. So
I will say nothing. I'm not in a position to comment on cases.
oh, okay. It was basically an internal services. One of the services that they offer, and staff have access to, they have birthright access to spin up their own machines. So
Is that is that part of that giant OpenStack instance that got up there?
I don't know.
I believe the one Chris Layton
Yeah, that's exactly one.
has ties to is the one.
Okay. Let's say
I'm dancing around things.
Okay. I don't.
You, yeah.
one person who has to be authentication is the person who manages that.
What did Chris do his Ansible talk here as well?
I think so. It's kind of
Did Chris Layton's Ansible talk here as well? I can't remember if that was Lobster or here. Okay. I saw it. I don't remember if it was with this group or with Lobster. It was in this room, but that doesn't tell me much.
So a little late now, but here we can see that the Jupyter demo actually has an HTTPS certificate working. Yeah, and not really much that can be done. All the scripts are available on GitHub, and if you want to spin it up, you can also tear it down really easily because you can just...
And if you've got a Google account you haven't redeemed your $300 free for, you should totally do that.
That is...
I enjoy it.
Just to show that off, yeah, so I've been running it for a little bit, and I've been doing a bunch of other stuff too, and I still have $130. So if you have a company Gmail account, you can use that one too, because they get $300.
Every Google account you have gets $300.
Do aliases count too?
Aliases are not set to Google accounts, but if you have Google Apps, like the free one, you can create 100 users, and that's 100 separate users. So if you delete it and create a new one, it's $304.
Based on one credit card?
If you do Google Apps free, you just need a credit card. There's no credit card at all. The old Google Apps.
But how do you link it back to your? So you don't link it back to your other domain.
No, you don't have to. If you don't hit the market, they never do. They'll just start cutting your services off.
Yeah, I don't think I've added my billing information here, but it is also under Quansight, so
it will go to them.
it probably would default. But this is as easy as it is to end it. You just hit delete on the Kubernetes cluster. Everything dies, I think, except for the disks. And
that sounds pretty reasonable.
yeah. So you can pick up the disks, and I believe they're under Compute Engine disks. And these will, they'll still be there. Other cool little Kubernetes things, so they have their own storage provisioner. So it actually whenever you ask for, say, a 10 gigabyte disk attached to your pod, it spun it up here.
So so is the registry for Kubernetes just hiding behind GKE somewhere?
I'm actually I'm just using Docker.
Oh, sorry.
The public one.
The SCD registry, not that one, the public registry.
The SED. So are you talking about the trick? So
No,
GKE actually hosts everything for you.
So it's hiding it.
Yep.
Okay.
Yeah. So etcd is actually being run on their end, which is one of the beauties of their service, because you can actually spin up a one-node cluster with GKE, which I imagine you can probably do with the other ones too.
Yeah, it's just not recommended.
Yeah, and I ran my home lab with Kubernetes for a little bit, and one of the biggest issues was having that master node be separate from the workers.
ChorusSync is a wonderful tool. You ever heard of ChorusSync and PaceMaker?
Okay.
If you've ever heard of them, they're kind of older style HA things in that they only manage where it's running and not installing the software.
Okay.
But if you already have some type of configuration management, they can do a very good job of, doing things like keep 3 copies of this alive across those 10 nodes, and you can even have them drag floating addresses around.
Huh.
They're actually really cool, and I only really got into them a little bit ago. But they can do some of the scheduling tricks that Kubernetes can do, and some of them Kubernetes can't do.
Okay.
Would Terraform do that also?
Terraform could create it in GCP, but Terraform is generally not concerned with what happens on a machine once it's built in provision. It doesn't really do anything continual. So where ChorusSync PaceMaker can take care of, oh, it died, or oh, this node is gone, and they're going to start it up on another one. Terraform, once it's running, Terraform, okay.
Yeah.
Should I stop the?
Yeah.
It can also do stintthaw, which is when you have a node that is no longer responding.